Hello everyone, my name is Amisha Chauhan, and in this video, I'll be presenting how a real world problem like food waste and hunger can be modeled and solved using network flow. So Ramu and his family don't get enough food regularly, but this is not because food doesn't exist. Nearby restaurants are throwing food away. So the problem is not food, it is the movement of food. If we think about it carefully, food has to travel from one place to another through roads, through people, through systems. And each of these paths has a limit. You cannot send unlimited food through one route. This is exactly what we study in network flow. How to move something from source to destination through a network with capacity constraints. To solve this problem, I converted the real world situation into a network. Restaurants act as a source because they generate excess food. NGOs act as intermediate nodes because they collect and distribute foods. Areas or people in need act as a sink where food is finally consumed. The paths between them represent possible routes for the food delivery, and each route has a limit. This is called food capacity. Just capacity. Over here, the capacity is 12, 8, so on for each of the edges as shown. 20 units of food is available in the restaurant. The bottleneck for the first route, whatever we choose. So for the restaurant to NGO 1 to area 1 is 8, and so on to all of them is 8, 4, and 5, 3 respectively. Adding all of them, we get 20. And that becomes a maximum flow. So far, we assumed that all the routes are usable. But in reality, food is perishable. If this route is too slow, the food will spoil before even reaching area 2. So we need to remove this path from the network. Now let's calculate the flow again. By modifying the network based on real-world constraints, we compute a more realistic maximum flow. So over here, the maximum flow becomes 15 instead of 20. The time complexity of 4 full Gaussian is shown, where E is the number of edges and F is the maximum flow. So this means that the algorithm becomes slower as the network grows or as the flow increases. It can also be solved more efficiently using Edmund Card. So this approach not only solves a mathematical problem, but also provides a structured way to handle real-world resources distributions efficiently. Thank you.